Hey everybody, this is Mr. Longo, and in this video we are going to cover writing equations of hyperbolas. And this should not be very difficult at all because you're just going to use some of the information to write an equation. Nothing too crazy. So, when we are given a hyperbola, remember you have a difference between a positive and negative squared variable, and that is the direction it opens. So since this example is opening left and right, we are going to have a positive x and a negative y. Okay? Center is at 2, 3. That means we're going to have an x minus 2 squared, and then we're going to have a y minus 3 squared, of course, equal to 1. Since it is opening left and right, we have a negative y. Okay? Now all we need to do is find our a squared and b squared values that go underneath our x and y. X is the distance from the center to the vertex of each side. That's 3 units away. So 3 squared is 9. And underneath y is just to the top of our box here. So we're just going up 2, which means 2 squared is 4. And game over for that problem. We're moving on. The next one, it says that we have vertices at 1, 5 and 1, negative 1. And then we have a focus at 1, negative 7. So that is going to give us a little bit of math to do here. But if you have a vertex at 1, 5 and another vertex at 1, negative 1, that will help you determine where your center is. So again, this is 1, 5, this is 1, negative 1. That is 6 units away to get from negative 1 to 5. So that means your center is 3 units away from each, which makes this guy over here 1, 2. So now we know where our center is. So we're going to have an x minus 1 squared and a y minus 2 squared, of course, equals 1. But now the other thing you need to take into consideration, it says that the vertices are here and here, meaning this one opens up and down, which makes x our negative variable. Now again, you could do y minus 2 squared minus x minus 1. Again, the order doesn't really matter. I've seen it both ways. Use the way you want to use. So now, a couple things. We know that underneath our y, this is, as we've already talked about, 3. So underneath y, we're going to have 9. But now we need to figure out what we're going to put underneath x. And that's where the focus comes in. Our focus is at 1, negative 7. So way down here, we have 1, negative 7. But then again, that distance is c. So the distance from 2 all the way to negative 7 is c. So c has to equal 9. So c squared is equal to, with a hyperbola, it's a squared plus b squared. That means 81 is equal to, we already know one of our terms is 9. So 9 plus b squared, subtract the 9, you get 72, is equal to b squared. So you get the square root of 72 for b. But remember, we're putting the 72 under x because b squared is what we need. Okay? And that's it for that example. The last one is a little bit easier than the previous one. If you'd like, just pause the video and give it a shot on your own. And when you're ready, click play. We'll see what you did. Okay, so it says the conjugate axis is 6, and you have vertices at negative 1, negative 2, and you have another one at negative 1, 6. Okay, so if that's where your vertices are, again, we know that this is opening up and down. But this time it also gives you the fact that you have a conjugate axis of 6. Conjugate axis, remember, that's the distance from, I guess, your box edges. if we were to create a box, and since this is opening up and down, we know our conjugate axis is going left and right, which are 3 units apiece. Again, from 6 to -2, that's 8, so we know this is 4 and 4, making our center -1, 2. So this guy, we're going to have an x plus 1 squared, and we're going to have a y minus 2 squared equals 1. We know our y is 4, so 4 squared is 16. And our x direction, we have 3 squared is 9. And since we are opening up and down, we have another negative x. And again, we're done with that example. So that's it for these. All you need is a little bit of information, plug it in where it goes, and you should be good. So this is Longo, and I'm out. See you, bye.